All right, guys, this is the last section in the chapter, which should tell you something, right? Test coming up soon. The good news is this is the last time you have to look at my face this week. Shut up, Anna. She's blessed. Okay, so last time that we meet this week, right? Because we have B-Day tomorrow, testing on Wednesday, B-Day on Thursday, and I don't know what next week. I think six. CSI test. It's an in-house test. It's not part of your regular test.
It's like
Monday's President's Day.
Okay, so what we need to learn now is solving logarithmic and exponential equations. So we need to throw some problems at you. Here we go. I'll write the first one up here. And you know what? We pretty much know how to do these already. We're just going to learn some processes involved here. So first one, how would I solve this right here? I shouldn't even have to tell you, but ready, set, go. Dude, try it. I'll give you about 20 seconds. All right, Ami, talk to me. You're the man. Okay, go ahead.
do this as a log base 1.5.
So, a base 1.05, that's what that is. How do you cancel a base 1.05? You need a log base 1.05. So, throw that on both sides. Log base 1.05 of 2. Log base 1.05 of this stuff. And I end up with log base 1.05 of 2 equals x. And I need a little formula for this thing. What's it called? Change of base formula, which has just been log of 2 over log of 1.05, which is approximately, somebody help me out decimal wise?
32.7.
32.7 according to Jack. Is he right? Jack's got your...
Am I right? Oh, no.
Did he lie to us? Jack's not got your back.
Ain't got it today.
Alright.
Okay. It's
What is it?
14.2.
Okay, so 14.2. Does that sound about right, you guys? Alright, this was simple, wasn't it? What's the key to all of these kind of exponential equations? The inverse function. A base 2 is a log base 2. Those are inverses, right? So if you just keep in mind the inverse functions, you'll be able to solve these, won't you? Any questions on this? All right, next idea. Logarithmic equations. Okay, so how about I give you this? Ready, set, go. Solve that one. Keep those inverse functions in your brain. Anybody know whose backpack that is over there? Not yours? Okay. Somebody left it here last week. Got the drum roll and the countdown. 9, 8, 5, 3, 1. Are we good with this? We good? Alright, so Mason, gonna put you on the spot. What log base is that? What's the little log base? It just says log. That's a log base 10. What cancels out a log base 10? The base 10, right? So, I need to put a base 10 here and a base 10 here. I should have done that in a different color, but I will. And I get this. 3x minus 1 equals 10 to the 8th power. What's next? I'm looking for exact answers here. Add 1. So we have 3x equals 10 to the 8th power plus 1. And I get this. 10 to the 8th power plus 1 over 3. So if I say exact answers, that's the exact answer, right? Now you can put that in the calculator and it'll come up with some answer. And it might be an exact answer. Or it might be some weird ugly decimal that goes on forever, right?
No, it's actually it is.
Okay, so give me the actual answer.
333,333,333.67.
2/3 then, right? 0.67 is 2/3, isn't it? So that's also the exact answer. But if you write 0.67, you rounded it, didn't you?
No, it's actually just 0.67.
No, it's only because.
Oh, it came out. Okay. Well,
It's only 'cause
I got
it's-
booted off down. So 0.67. Are we okay with that? So if you're not rounding, then this is exact and that's exact. We're fine, right? But if this came out to be some never-ending decimal, you don't want to round it. If I'm saying exact. Any questions on this? We good? All right. This got harder. Okay, well, here's where we run into problems. Let me show you what you cannot do. Put your pencils down, just listen. You cannot just go like this. Log 10, base 10, base 10, base 10. You hear what I'm saying? Doesn't work that way. So when you see logs and you're trying to solve them, you always want to try and combine logs if you can. That will only give us one log, won't it? And what's the rule for combining these two logs? Log
3x minus 2 over 3x.
Now I can actually just take my log of both sides, right? And if I do that, I get it's a 10 here and a 10 here. And I get 3x minus 2 over 2x equals 10 to the 8th power, some big huge number. How about we put this over 1 and cross multiply? We get a big number, but I get this. 3x minus 2 equals 2x times 10 to the 8th power, correct? Well, that was hard. That 10 to the 8th power, isn't that just a number?
Yeah.
Can't I just write it as a coefficient then? What's 10 to the 8th power? That's a 1 with 8 zeros, right? So this is the same thing as 2 times 1 with the next answer, right? I know that that looks weird, but that's all that is. It's just this. Put a 2 in front of that, right? That's 200 million x. Crazy, but that's what it is. 1, 2, 3, 4, 5, 6, 7, 8. 200 million x. Crazy, right? And it's blowing our minds, but we have to combine, don't we? Combine variables, get some things together. How about we subtract 3x? I know it looks really weird. What do you get? Take 200 million and take away 3 from it. What do you get? 1, 9, 9, 999, 997, and an x. We subtracted 3 from it, right? And now, Divide. You're gonna like this because the answer is gonna beat your brain up in a second.
It's
So we have a negative 2 over that thing right there, right?
-1 times.
And Anna says the answer is negative some little tiny decimal, right? Ami says that? Okay, guys, this is what you must always do with logarithms. You have to check your answer. Now, sometimes you just use common sense. Can we take a log of a negative number? Remember what the graph looks like. It looks like this, right? Is it over here at all on the x-axis? Can I take like the log of negative 10? Put it in the calculator. See what you get. Log of negative 10. You get that?
There.
Okay. In other words, when we plug our number back in, if it gives us a log of a negative, we have a problem, don't we? Okay, so let's look at this. This is going to basically be 0, isn't it? 3 times some teeny tiny number. You agree? Minus 2, I'm going to have a negative on top, aren't I? You agree? And this is going to be 2 times a negative, which is going to be a positive, isn't it? So negative over, sorry, I'm ahead of myself. This is going to be a negative, and this is going to be a negative. 2 times a negative is going to be a negative over negative, right? Which would be, we're okay then, right? You just have to check to make sure you haven't turned your log into a negative number. So we just did it. We're fine. The answer's fine. I don't actually have to plug that back in. Just use some thing, common sense. I just threw that one out there like willy-nilly, and that was a weird one. Let me give you one that's not quite so crazy. Try this problem. The log of, if I could read this, 2x plus 1 equals 1 plus the log of x minus 2. You guys try that one. We're almost done here. Think about that first step. We don't want 2 logs. Can I just take the log base 10 on both sides of this thing? That base 10. Can I? Can I go base 10, base 10, base 10? No, I'm not allowed to do that, am I? Okay, so think about it. In the interest of time, I'm going to go ahead and write it here. Brought it over, does that make sense? Combine it into one log now. Take to the base 10, which gives me this. 10 to the first power is just 10, right? Cross multiply, solve, and you should get x equals, figure it out. And then we've got to double check to make sure that the answer didn't give us a negative log inside the parentheses, right? All right, finish it out. Jack, what'd you get?
I got 165.
What? You got what? Talk to me.
X equals 2.65.
As a fraction, was that 21 over 8? Okay, so the answer is x equals 21 over 8. Now, and you said that is 2.625. If I put a 2.625, that's going to give me
Just 165.
a positive number, okay, right? If I put a positive in here, we're okay here too, aren't we? So when we go back and check, we're fine. We didn't create a problem for ourselves. That's the answer. Are there any questions? All right, let me shut her down. Bada bing.